All right, in this video, I'm going to show you what to do today. I'm out with a couple, well, one sick kiddo, and my other kid is home because her preschool leader is sick, and it's like a single leader, so it's not, the whole preschool gets shut down when the one person is sick. So I'm at home taking care of two of my kids, and so I'm going to show you what you need to do. So first, today, regardless of where you're at currently in the process, I want us all, for the sake of simplicity, because I'm not here, and to make this video most effective, I want you all on this page to start. So in this investigation, we're going to be working with this device. And so you're going to need some of these aux cables. Actually, they're mono aux cables. Okay, and there are definitely people in the room who can help you find out where those are at. They might already be plugged into these modules from the last time. Remember, you need a 15-volt power supply. Make sure your power supply is correct. And yeah, you can go ahead and turn it on. Now, in a couple of places it says, hey, ask Peter to help you set this up. Well, that's what this video is to help you do. Okay, so at first it says, use the dual VCO and data modules to experiment with the following controls. Ask Peter if you need help setting up. Okay, so this one is pretty straightforward. All you're going to do is you're going to plug in the sine wave here, okay? And you're going to turn on the oscilloscope by just clicking into it, and you're going to plug it in. And you should get a sine wave. And if you don't, then either you need to like turn these range and tune controls maybe down if you're not seeing a sine wave of some kind. Or you need to get it out of LFO mode, because if there's switches in LFO mode, it'll just go up and down and not actually see a sine wave. Okay. It also could be that this half is not working and you need to use a bottom half. This and this are just the same circuit, just twice. So if it wasn't working up here, you could plug it in down here. I'm on LFO. There we go. So the goal is to just make sure you're seeing a waveform over there. The other thing that will help with this investigation is to press the trig button over here. So it's the, I believe, second button in. Yeah, 1, 2. Press it, and then you can't read this on screen, but the first option says mode, and you want to go from auto into normalized mode. And so I'm going to zoom in here just for a sec here. So if I click on this white knob, click, and then turn it into normalized mode, you'll see that it just is attempting to take that wave that is redrawing and making the animation look crazy into a still wave for easier seeing what's going on. So I recommend using normalized mode. Okay, and then let me click out of that, press that button. Okay, and then you're ready for that first set of investigations. Okay, so you can pause the video right here and do this investigations, and then I'll talk to you about the next section. Okay, all right, in the next section, it just says, hey, go ahead now, plug a speaker in or headphone into the output of channel 1. So just a quick thing here to do that. You can actually plug headphones directly into there and you will hear something, but only out of one side. If you want to hear it on both sides, you're going to plug in here and then into this green input right here, and then you can flip the speaker on or listen through headphones. Okay, we've done stuff like this before, but this is the first time that it's like totally independent. I want you to investigate. I want you to do like the work of figuring out how this thing works, because in order to do the mathematical modeling, you need to create sounds with this, so you need to understand its core functionality. Okay, then the next page will be about investigating how this module works, what information it can analyze and show you, what are some of the different modes on it, and there are some recording of some different like things on one of the parameters, like what do they do, These will be important in later investigations. So you need to go through that whole process. When it says discuss, discuss. When it asks you to write something down, write it down. You'll notice there's not a lot of writing here. There's a lot of discussion points along the way. And so you need to do this with a partner, as it says up on a partner or group, as it says up on the whiteboard. Okay, and it also says on the whiteboard, if you have a device, that's a device for no more than 2 people. So you can't have 3 people on one device. You can have 3 people working together, but one of those persons is on a second device. Okay, anyway. When you're done with all that, it has another, ask Peter how to show the, set up this investigation. Okay, and so this one's a little bit more straightforward. Or sorry, a little more, not straightforward. It's more close to what we have been doing. And so what you're going to do is you're going to plug in to the, you're going to take, instead of coming straight from here, you're going to go from the silver output, and then this is going to go, whether it's sine, triangle, square, or saw, that's your choice. Let me put in square here. Okay. I'm going to plug this into the input here. Okay. And then the last thing you want to do is just go gate to gate. And this will make it so that when you press the button, an action happens over here. And if I turn the sound on, let me turn the sound actually on. Anyway, over here it might talk about the cells module on this piece of paper. The cells module or the sequencer module, they perform the same duty. We've done this before. And so that's the core setup there, but it does ask you to do a couple of things to get started, and that's to turn the attack, decay, and release knobs fully counterclockwise, so it's fully down, and the sustain knob fully clockwise. A thing that we've done before, and it's just talking about these knobs here. 1, 2, 3, all the way counterclockwise, this one all the way clockwise. Okay, and then you just follow those processes. And then you get to this thing, and then it says plug an output of dual VCO through the shifter, okay, and unplug the speaker. So an output meaning one of these sine, triangle, saw, square into through the shifter. And so what that means is just instead of going in and out of the VCA, which is the silver one, just go in and out of the shifter. Now, it does tell you to turn the speaker off, okay? But go ahead and go through the shifter. Now, when you're through the shifter, a couple of things, like first of all, you can see just how crazy this one is. A couple of things that'll help you understand what's happening better. One, if you take the normalization off and then go over to the range and tune controls and tune the circuit in such a way that it slows down the graph. There we go. So that the redrawing of every animation is more still. And that will help you better see what's going on. Okay. Now I'm going to phase shift this back out. Okay. And you can see a little bit what might be happening in this sort of thing with the shifting. There's some weird stuff that's happening around there. And there's a conversation to have about what's going on there. In order for this to work, it says it right in the text. So again, if you're just reading the text and doing it, you don't, I'm just pointing out the things that students don't read. So it says to turn this fully clockwise or else the whole circuit doesn't work properly for this experiment. It doesn't, it still works. It's just not for this experiment. Okay. And then if you manage to get all the way through there and still have some more time, it does talk about the additive synthesis waveform generator link in Schoology. Well, we don't have Schoology. This is the same file that I had you zip file that I had you download earlier and open up the website. So the link to it, to that zip file, to download, extract, you have to download, extract all that sort of stuff, is still the same as it was before. If you still have it if you were able to get it to work before, then you don't need to re-download it. You should have it somewhere. So tiny.cc/harmonic synth. Okay. And then it just guides you through a very similar experiment, almost identical to what you've done before, but again, independent without me guiding you through it. The goal is not necessarily to learn things one time and then never come back to them. We need to come back to them again and again because you need to know this stuff deeply. You need to remember it and keep those ideas in your head because we're going to start to model them and apply them. And if those fundamental core ideas aren't something that you are wrestling with and understanding how they work together, how we perceive sound, how the shape of a wave affects what's actually in the wave, the frequencies that we hear, if you're not wrestling with those ideas, then the mathematical modeling is not going to make any sense at all. And so that's why we do these things twice at the front end. So it might feel like, hey, I've already done this. Do it again. Take it really seriously. You'll probably notice something this time that you didn't notice the last time, and really want to cement it. I'm just going to double check before I end the video that that URL is correct, because I would hate to send you somewhere that is, yeah, it's still up there. It's a zip file. Again, you have to download and extract. And there you go. And if you somehow finish all of this in half time, there is an exceeding section right after this. That's a further exploration into the depths of what this modular synth can do. And that's it. Okay. And when I come back, hopefully on Tuesday, and I expect to see real progress on this. Okay. I'm not going to slow down just because I'm not here. There's plenty of resources for you to get this stuff done, and I expect you to support each other and hold each other accountable to get this stuff done. All right. I hope you have a great day.